Hello, and welcome to today's lesson on the practical applications of different electromagnetic waves. Today we will learn about the applications of radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Let's get started. Let's start with radio waves. Radio waves have the longest wavelengths in the electromagnetic spectrum and the ability to travel long distances without significant attenuation. We've already touched on some of the applications of radio waves, but to recap, radio waves are crucial in broadcasting television signals. Their long wavelengths enable the signals to cover large areas and penetrate physical obstacles like buildings and foliage. This ensures that TV programs can be broadcasted to a wide audience effectively. The same properties make radio waves ideal for transmitting audio signals in radio broadcasting. They can carry these signals over large distances using relatively low power, making them efficient for widespread communication. Moving on, we have microwaves. These have shorter wavelengths than radio waves but longer than infrared waves, allowing them to penetrate the Earth's atmosphere effectively and interact with water molecules. Microwaves are perfect for satellite communications because they can pass through the Earth's atmosphere with minimal loss of signal. This makes them reliable for transmitting data over long distances, such as from Earth to satellites in orbit. In microwave ovens, microwaves are absorbed by water molecules in food. This absorption causes the water molecules to vibrate, generating heat that cooks the food quickly and evenly. On to the next EM wave. Infrared waves have wavelengths longer than visible light, but shorter than microwaves. They are effectively absorbed by objects, making them useful for heating and imaging. Infrared waves are used in electrical heaters because they can transfer energy directly to objects, heating them efficiently without significantly warming the surrounding air. Infrared cameras also detect thermal radiation emitted by objects, allowing for night vision and surveillance applications. They can capture images based on heat, which is useful in security and military operations. Finally, infrared waves are commonly used in remote controls for TVs and other appliances. The waves transmit signals to the device being controlled through a line-of-sight path. Next up, we have the EM wave most familiar to us, visible light. This has wavelengths that fall between ultraviolet and infrared waves. It is highly effective in data communication and medical technologies. For example, visible light is used in fibre optic systems because it offers high bandwidth and low signal loss. This allows for the rapid and reliable transmission of data over long distances, essential for high-speed internet and telecommunications. Lasers emitting visible light are also used in various medical treatments, including laser eye surgery, LASIK, and dermatological procedures. The precision and minimal invasiveness of these lasers make them suitable for delicate medical applications. Moving on to ultraviolet waves. These have shorter wavelengths than visible light, giving them higher energy that makes them useful in both illumination and disinfection. For example, ultraviolet radiation can cause certain materials to emit visible light, fluorescence. This property is harnessed in fluorescent lamps, which are more energy efficient than traditional lighting. UV light is also used in fraud detection, where special markers are designed to fluoresce under UV light. Ultraviolet lamps are also used for disinfection, effectively killing or deactivating microorganisms in water treatment, air purification systems, and medical facilities. Finally, controlled exposure to UV radiation in tanning beds stimulates melanin production in the skin, creating a tanned appearance. Lastly, let's look at the applications of X-rays and gamma rays. On to X-rays and gamma rays, these waves have very short wavelengths and high energy, making them capable of penetrating most materials, which is vital for medical imaging and treatment. Specifically, X-rays are used in radiography and CT scans to image bones and internal organs. Their ability to penetrate through soft tissues while being absorbed by denser materials like bones creates clear diagnostic images. Gamma rays are used in radiation therapy to target and destroy cancer cells with minimal damage to surrounding healthy tissues. In summary, each type of electromagnetic wave has unique properties that make it suitable for specific applications in communication, medical imaging, heating, cooking, and even fraud detection. In today's lesson, we delved into the practical applications of different electromagnetic waves, emphasizing their unique properties. We covered radio waves, highlighting their use in television and radio broadcasting. For microwaves, we discussed their role in satellite communications and cooking. Infrared waves were shown to be crucial in heating, food preparation, infrared cameras, and remote controls. We then explored visible light's importance in fibre optic communications and medical lasers. Ultraviolet waves were noted for their uses in fluorescence, energy-efficient lamps, disinfection, and skin tanning. Lastly, we examined X-rays and gamma rays, focusing on their applications in medical imaging. Watch the rest of the GCSE physics course at Sophos Education.